Welcome to aminacademy.com. In mathematical economics, let us explain the constraint optimization with Lagrange multipliers. In calculus, which is used to maximize or minimize a function subject to constraint. Given a function that is f of xy subject to constraint g of x comma y equal to k, where k is a constant, a new function f can be formed and we can optimize. Look at here, the given function is f of x comma y. Subject to constraint equation is k of x minus y equal g of x minus y equal to k. A new function f can be formed by the constraints equal to 0. That constraint equal to 0 means here k minus g of x minus y equal to 0, then that is substituted here. Therefore, the constraint equal to 0, we can get f of x comma y comma lambda equal to f of x comma y plus lambda times k minus g of x minus y, where lambda is Lagrange multiplier. This lambda is Lagrange multiplier. Here, f of x comma y comma lambda is Lagrangian function, and f of x minus y is the original function or objective function. From the function f of x comma y comma lambda equal f of x comma y plus lambda times k minus g of x minus y, we can get by partial derivatives. That is, from this function we can get f of x, fx, that means dou by dou x, partial derivative of this function with respect to x equals 0, and partial derivative of with respect to y equals 0, partial derivative of this function with respect to z equals 0. All these are linear system of linear equation. By solving these equations, we can get the values of x, y, lambda, and by substituting these values to the function f of x comma y comma lambda, we can get optimize the function here. Now we'll do an example so we can understand this concept very clearly. Look at here. First example, optimize the function z equal 4x square plus 3xy plus 6y square, subject to the constraint x plus y equal to 56. X plus y equal 56. Look at here. This original function is z equal 4x square plus 3xy plus 6y square. Subject constraint function is x plus y equal 56. From the constraint equation, we get 56 minus x minus y equal to 0. That means we are collecting one side, 56 minus x minus y equal to 0. This we have to substitute in this function, original function. Therefore, z equal, the original function is 4x squared plus 3xy plus 6y squared plus lambda times 56 minus x minus y, where lambda is Lagrange's constant. Now we collect, look at here, this is the function. Now differentiate it. with respect to x, y, z. What is dou z by dou x, which is, you can say it is zx. Here, with respect to x means derivative of this one is 8x. Here, derivative of this y, treat y as a constant, that is 3xy derivative is 3y. 6y square 0 plus lambda into 56 derivative is 0, lambda x is minus lambda. Here, lambda minus lambda y derivative is nothing, 0. So we have to equate this to 0. Then dou z by dou y, which is equal to zy. Similarly, you have to differentiate with respect to y. This is 0 because only x. Here, derivative of with respect to y is 3x. Here, 3x. Here, this with respect to y is 12y. Then lambda 56 lambda 0. Then with respect to y is minus lambda. Then dou z by dou z is equal to z, which is not to z dou z by dou lambda, that is z lambda, or z lambda equal, look at here this with respect to lambda 0, with respect to lambda 0, here this is minus lambda x, derivative is minus x and minus 1. 56 lambda is 56. Derivative of 56 lambda with respect to lambda is 56 minus x minus y equals 0. These are three equation linear system. So we have to solve these three equations. We can get x, y, lambda. Now look at here. First, from 1 and 2, from 1 and 2 subtracting 1, and that is 1 minus 2. 1 minus 2. If you subtract from 1 the 2, we can get the lambda will cancel. 8x minus 3x is 5x minus 3 minus 12 is minus 9. Minus 9y minus 9y equal 0. And this, let it be equation 4. And from this, not necessary to give the name here, from this we can get x equal 9 over 5y, which is equal 9 over 5 is 1.8. X is 1.y. Substitute in any equations. Look at here, this. We can substitute that equation 3 gives lambda 56 minus x minus y equals 0. 56 minus x minus y equal to 0. Then 56 minus x is 1.8y minus y equals 0. Then 56 equal 1.8 plus 1.8 is 2.8. Go that side is plus 2.8. 2.8y. Therefore, y equal y equal 56 over 2.8, which is equal 20. Y is 20, therefore x equal 1.8 into y. (36). Therefore, we got x is 20, y is 36, substituting an equation, any one equation, subject equation first. Then equation 1 gives, equation 1 is what? 8x plus 3y minus lambda. 8x minus 3y minus lambda equal to 0. Then substituting the values of x and y, we can get the lambda values. 8 into 36 minus 3 into 20 minus lambda equal to 0. 48, 4 carries. 228 minus 60 equal lambda. 228. Lambda is 228. Look at here. Here we are getting 56 minus x minus y equal to 0. 56 8x plus 3y minus lambda equal to 0. 8x minus 3y Now substitute in another equation, that will get 56 minus, no, here that equation 56x, then 56 minus that equation 1 gives 8x plus 3y 8x plus 3y minus lambda equal 0. 8 into x we got 36 plus 3 y 8x plus 3y 3 into y we got 20 equal lambda. Then 8 into 36 is 6 8s are 48, 4 carries 28 plus 60 equal lambda. Therefore lambda I get 348. We got all values which are equal. Look at here, x equal to 36, y equal 20 and lambda equal 348. We have to substitute these values in original, that is optimization equation, that is z equal, what is z, 4x square plus 3xy 4x square plus 3xy plus 6y square plus lambda times that this function plus lambda times 56 minus x minus y. 56 minus x minus y. This is optimizing equation. 4 into, I have to substitute the values of x is 36 square plus 3, x is 36, y is 20 plus 6, the 20 square plus lambda equal 348. 56 minus 36 minus 20. By substituting these values, we will get z equal 9744. This is the optimizing value of this function. So far we discussed about what is optimization of the function with Lagrange's multipliers. As well, we did some example problem to understand this concept. We have that. Please subscribe our YouTube channel.